Hello everyone, welcome back to my channel. Today is day 8 of solving Geeks for Geeks problem of the day, and today's question is left view of binary tree. So the question says here is given a binary tree, return left view of it. Left view of a binary tree is a set of nodes visible when tree is visited from the left side. So we need to complete the function left view which accepts root of the tree as an argument, and if there is no left view, we need to return an empty tree. So the left view of the following tree would be 1, 2, 4 and 8, as we need to view it from the left side of the tree, and remaining nodes will be overlapped behind that particular front nodes. So coming to this example, the left view of it would be 1 and 3, as 2 will be overlapped behind 3. Coming to the second example, the left view of this particular tree would be 10, 20 and 40. 30 and 60 would be overlapped behind 20 and 40. The approach here would be to take the level order traversal of this particular binary tree, and we need to take the firstmost value of each level's nodes. So the level wise values would be 1, 2 and 3 at second level, 4, 5, 6, 7 at the third level, and finally 8 at the last level. We need to take each and every firstmost value of each and every level. So the answer would be 1, 2, 4 and 8. So in this way we can find the left view of a binary tree. So let's try run this approach with an example, and then let's code this particular approach. Here I have taken a binary tree, and as you can see from the diagram, the left view of the binary tree would be will be able to see only the nodes which we can see from this particular left side, and we can only be able to see those nodes like 1, 2, 4 and 8. So output we need to return in the form of vector as 1, 2, 4 and 8. As we need to take the level order traversal of the binary tree, we'll definitely use Q as an data structure. So initially what we'll able to do is to take the root into the Q. We'll pop that particular value and push it into the answer vector, and then we need to check if that particular current node has both left and right values attached to it or not. If there are, then we need to push those values into the queue. So the queue contains 2 and 3. Again, we need to run the loop until or unless the size of the queue becomes empty. Since initially the size of queue was 1, we have run the loop one time, and we have came out of that particular loop. Now the size of the queue would be 2, so we need to run the loop 2 times. Before running the loop 2 times or n times, we need to pop the firstmost element of the queue, and we need to push it into the answer vector, as we need the firstmost value of the tree at that particular level. So here before running the loop, we'll take the firstmost element, which is 2 here, and we'll push it into the answer vector here, and then we'll check the values of the 2, whether it has left node or right node attached to it or not. Here we have 4 and 5, so we'll just push 4 and 5 into the queue by popping out 2 here. So again, since as I said earlier, we need to run the loop n times. Here next value would be 3, since we need to pop 3, and we need to push its left and right nodes into the queue. So it will the queue contains 6 and 7 at the end of the queue. So now the queue contains 4, 5, 6 and 7. As we have run the loop 2 times, we'll get out of the loop, and again we'll take the firstmost element of that queue, which is 4 here. We'll pop this value, and again we'll just push it into the answer vector. Again we'll just find its left and right node values. It doesn't have left value, but it has right node value, which is 8, and we'll just push it into the queue at 8. So as now it has 4 size, we'll run the loop 4 times, and we'll push all those nodes, left and right nodes, into the queue until or unless the queue becomes empty. So after popping out 4, we'll push 8 into the queue. Again we'll go with 5. It doesn't have left and right null, So we'll just pop it out from the queue. Again, the queue contains 6, 7, and 8. We'll check whether 6 has left node or right node. It doesn't have, so we directly pop it out from the queue. Again, we'll check 7. 7 does not have left and right child, so we'll directly pop out from the queue. So we have run the loop 4 times. So we'll come out of the loop and we'll again take the firstmost value of the queue. So here we'll take 8 here, and we finally check whether it has left node or right node. It doesn't have left node or right node, so we'll directly pop it out from the queue. Here the queue becomes empty, and we'll get out of the main loop, and our answer vector would be filled with all the required left view nodes of the binary tree. And finally we'll return that particular vector. So let's code this approach. So the code goes like this. We need to take an vector, answer vector, and initially if root is null, we need to return that answer, which would be empty initially. Then we'll take the queue of node. Initially we'll push the root into the queue, and we'll run a loop until or unless the queue becomes empty. Before running another loop, we will grab the size of the queue. As I've said earlier, we need to run the inner loop until or unless the size of the level becomes empty. So before running the loop, we'll just push the firstmost element into our answer vector, which would be q dot front value, which can be accessed using data. And we'll run the loop till n times. We'll access the frontmost value, which would be current value. We'll pop it from the queue, and we'll again check if this front value has left node attached to it or not. If it has, then we'll just push it into the queue. The same goes with right node. If it has right node attached to it, then we'll just push it into the queue. After all these iterations complete, we'll come out of this loop, and again we'll take the firstmost value of the next level. And finally, after coming out of the main loop, when the queue becomes empty, our answer vector gets all our required values, and then we can return this answer vector from this main function. Let's compile and run. It's working for now. Let's submit. As you can see, our problem got submitted successfully. Hope you like my explanation and video. Please give it a like and subscribe to my channel, and I'll see you in the next one. Thank you.